Honestly, this technique's like magic. The first time you see it and you see it in action, you're like, how's it doing that? It's really, honestly, it's one of the most impressive things I've seen. The challenge we're looking at is how to identify cracks and defects in buildings and other objects in a non-contact standoff way.
In the early days, we still had to make holograms, and we're using that 3D recording system to study how things move under load using holographic interferometry. Loughborough had invented a technique where instead of having it on a photographic film, we could do it on a TV camera. But we could then introduce optical differentiation. So we could actually, in real time, we could see contour maps of strain on an object. And that's critical for crack-sensitive materials. So in fact, what we can do is we can actually see cracks or defects within the concrete structure way before you can see it with the human eye. So it has the ability to look at the whole structural behavior from the surface and identify the crack formation within it. And we can also spot where the cracks are running, how they're running, and visualize that and get real-time data that can be then fed back to some sort of computer model to look for severity.
This is one that I'm really excited about. There's a lot of potential for this, lots of different areas I can see us using it in. So potentially, if you can deploy this technology on site, you can then say, look at a shorter preventative maintenance schedule and identify defects and issues before they become a real problem.
This is not new. We've developed this originally for advanced materials such as carbon fibre composites, etc. And that's given us the confidence and the technology to understand what the fringe pattern data means in terms of cracks and how to extract the data from that to start doing things like residual stress, residual life in a structure, working with the design authorities to really look at life extension, things like that, as well as, is the thing fit for purpose or not? Without the Game Changers program, I knew what the capability was, but I wouldn't know how to access the relevant people who might have the challenges, who were the problem owners in Sellafield. It's a big place.
I hope somebody at Sellafield will take this forward and actually start using it. We've got applications which are not just for concrete and steel, but we've got them for polymers and composites too. So I can see applications all over site for this. So for the next steps for this, I'd like to see a deployment which isn't based in concrete or steel. So I'll be looking to employ it for maybe a polymer or a composite wrap repair to see what's going on underneath that repair.
I think this could address a lot of issues very quickly and give everyone a lot of confidence. The opportunities are significant, and I think more importantly, it would give Sellafield the confidence, but having given them the confidence, they can then give others that confidence such that they can reassure the licence authorities and the public, etc., we're doing the right thing.